All right, guys, lesson 3.9, inclined planes. We're just going to add on friction, but it's pretty much a continuation of what you did yesterday. So let's draw it out. Man, I'm going to draw it down farther because it takes quite a bit of room to draw these. All right, so let's say 40-degree incline. Say we got a mass up here. Just say it's 10 kilograms. And we're going to add friction on. So I'm going to give you these mu's. So let's say mu s. Remember, that's that static friction. Say is 0.4. And let's say mu k is 0.5. Remember, mu k. I'm sorry, let's flip-flop those. Usually the static is a little higher. So mu s is 0.5, mu k is 0.4. Okay, and we're basically going to find the acceleration of this thing down the incline. Like yesterday, we're just adding on that friction force. Okay, I would recommend drawing these things extra big to kind of help you out. Remember, the gravity force always just goes straight down. That was that m times g. So in this case, 98 newtons. We found these components. So if we turn our page and come straight over, make this rectangle like this. Okay, so we had this component, y component we called it, and then an x component here. Okay, called this fy, this fx. That's all the same. None of that stuff changes. Okay, find my calculator. So remember fy in this case. Remember the 40 degrees went here. That's kind of a tricky thing. The 40 degrees goes in that little slot right there. So the fx, which we could put down here also, is going to be the sine. So that would be 98 times the sine of 40. Turn this off. 62. It's here, 0.99, 63.0. And then the fy is actually the cosine. 98 times cosine 40, 75.1. Okay, so you can put the 63.0 up here. All right, that's all the same. We're going to add on friction now. So remember the equation for friction we already have, actually, if you remember it. Let's just find both. Let's find the Fs max and the Fk. Remember, Fs max was mu s times the normal force. And then Fk was the mu k times the normal force. They're basically the same equation. Just different mu s or mu k. So how do we do that? Well, remember, normal force came up here. Your normal force actually canceled out this y component here. So that would be the 75.1 newtons in this case. Okay, it's not the 98 like before. So gravity force is not the same as normal force. That's kind of the thing that's different here. Okay, in this case, gravity force is not the same as normal force. Normal force is the y component of the gravity, actually. Okay, and then we can basically plug and chug here. So mu s was a 0.5 times the normal force, 75.1 newtons. This one will be 0.4 times 75.1. Should be able to do that in my head, but apparently not Monday morning. 37.55. I mean, we're rounding the nearest tenth, so I'm going to say 0.6, sorry. And then 0.4 times 75.1. 300.0. I'm sorry, 30.0. Okay, so what do these mean? As it's sliding, if it's sliding, so this remember meant that it would take more than 37.6 newtons to get it sliding. Okay. We should have drawn this on a picture here. Let's draw where that friction force actually is. It's actually really right here. This is like the friction. It might be static or kinetic. So do we have enough to get it sliding? Well, the 63 pulling this way and the 37.6 going this way, it would start sliding. So more than 37.6 would get it sliding. So in this case, it is going to slide because we've got 63 pulling it. That's the force pulling this way. That's, you know, the applied force, you could say, is the 63. So now how do we work with this 30? So let's just make this Fk equals 30.0 newtons. So now we can say, okay, how fast is this thing going to accelerate based on that? Well, the net force, sorry about the zooming here. The net force, if you think about it, you got 63 pulling this way, you got 30 pulling this way. So the net force is just going to be that 63 newtons minus the 30 newtons. That's easy. 63 minus 30 is 33.0 newtons. And then your A is just going to be your F net over M again, like we did before. Okay, so I'm getting 33 newtons divided by, what was it, 10 kilograms. It's only going to accelerate at 3.3 meters per second squared. Compared to if there was no friction, I don't know, your acceleration, it would have been 63 divided by, it basically would have been 6.3. With no friction, if you think about it, you would have done this as your F net divided by 10. So the friction slowed it down quite a bit in this case, almost cut it in half. Okay, so pretty much handle the problems like yesterday, but adding in that idea of friction. All right, there's 3 problems there, and one of them's easy, the other 2 are a little tricky. See if you can figure them out.